Hi, at this point we've already installed Fasten. Now let's take a look at a few code examples. I begin with the program bear.asm. First, we have the question of how to open this program. If you don't have any preferred text editor, you will probably use Notepad. In order to open Notepad, you first click on the Start button, or maybe on the Start icon, and then you can enter here Notepad. This is going to open the Notepad program. It is a very simple program where you can write text. Then we can just drag bear.asm into Notepad. And we can see the example code inside Notepad. As an example, using Microsoft Word will not be a good option for opening assembly files. That is because when you save using Microsoft Word, the resulting file will not be just plain text. It will have some more metadata, and the assembler will not be able to understand this additional metadata. Therefore, you have to use a very simple text editor. Notepad is one example. In this course, I'm going to use the Vim editor. This is how Vim looks like. You don't have to use it yourself, but this is what I'm going to use. Let's begin with what we can see inside the source code. This is, by the way, called the source code because this is the source of a program. This is where it begins. The assembler will later take this file and turn it into some kind of a binary file. First, we can see that we can recognize those four instructions: inc, dec, and inc. We already know what those instructions do at this point. Inc EAX is going to increase the EAX register by 1, and also the next one is going to do the same. Dec EAX is going to decrease EAX by 1, and so on. Inc EAX is about increasing EAX by 1. This is the known part of the file. We can really understand it at this point. Then we have this use32. Use32 is not an instruction. Inc and dec are instructions. However, use32 is something else. It is something we call a directive. It asks the assembler to do something. In this example, use32 tells the assembler to use the 32 bits code setting. We could, for example, ask for use 16 or use 64. If we wanted to. In this course, we are going to use the 32 bits code setting. Therefore, we use this directive, use 32. By the way, if you don't have any such directive about which bits code setting to use, the assembler will default to 16 bits code setting, which is usually not what you want. Therefore, if you write this kind of code, make sure to use this directive. Next, we can see that we have those lines which begin with a semicolon. We have one line here in the beginning of the program and another one here. Every line that begins with a semicolon is a comment. You can also use comments from the middle of the line to the end of the line. For example, I can add a comment here. A comment is a piece of information that the assembler ignores. All of those comments will be ignored by the assembler. You might be wondering then, why have comments if the assembler ignores those comments? The answer is simple. The comments are not for the assembler. The comments are for you. They are for you and for other people which are going to read this code. As an example, if you write some piece of code and then you come back to look at this code after a long time, you will probably not fully understand everything that you see. If you add comments to your code, it will be much easier to come back to your code after a long time. As another example, adding comments to your code will help other people not familiar at all with your code to be able to read it. It will make their life much easier if you add comments that explain what the code does, especially if the code does something complicated or very interesting. Now that we've talked about the inside of this code, let's try to use FASM to assemble this code. We will usually run FASM from the console, or maybe in another formulation from the command line. Let's begin by opening the command line. We click on the Start button or on the Start icon, and then we enter here CMD and press the return key. We get this black window, which is called the command line. You might be not familiar with this command line. You should not be worried about it. These days, most of the people only use graphical user interfaces to communicate with the computer. However, if you want to be a programmer, you do have to be familiar with this kind of communication with the computer, which is the command line. We are not going to talk so much about the command line, but I just want to show you the important things. The first one is how to traverse directories. At any point, the command line points to some location in the file system. Here it points to C, users, XOR PD. I want to get it to this path to be able to work with the files. In order to do this, I have to traverse the directories. I have to traverse the file system. First, let me show you how you go back in the file system. Currently, I'm in the C drive inside the users folder, and in the users folder, I chose the XOR PD folder. Actually, I didn't choose anything. This is just how the command line began. First, I go back. I use the CD command, and I add 2 dots. Then I do it again. Now, I'm at the C drive. At any point, I can change to another drive. In this example, I want to change to the D drive. So I press D and then a colon. Next, I want to traverse to this location. You can see this is a pretty long path, which would serve as a good example. Okay, let's traverse. First, I get into the projects directory inside the D drive. And then I keep using the cd command to traverse to other directories until I get to the wanted directory. By the way, if you were wondering, I use the tab key on my keyboard to complete the names of the directories. I don't really type that fast. For example, here if I press tab, I get it completed for me. This is very convenient. Finally, I got to the wanted path. As you can see, I have traversed all the directories all the way until the wanted path. If you use Total Commander, you could instead just use this line here and enter CMD here. And then you will begin from the correct path without having to traverse it yourself. Next, we want to assemble the file. We are going to use the FASM command. Then we type space, and then the name of the program that we want to assemble. You can see here that FASM and the name of the program are not on the same line. This could sometimes happen, for example, if the path is really long. Maybe in your computer, this is not how it is going to look like. And it is okay. You just have to make sure that you type in FASM, then space, and then the name of the program. Finally, I press the return key. I get some kind of output here, which says flat assembler, which is the name of the assembler, then the version of the assembler, and then the amount of memory used by the assembler. Usually, you will not really care about this information. The next line is a bit more specific to our program. It says that the assembly process took only one pass over the input file. By the way, FASM is a multi-pass assembler. Sometimes, if your source file is pretty complicated, more than one pass will be needed. The fact that we only had one pass over our source code means that it is pretty simple. Next to it, we have the size of the resulting program, or the size of the resulting binary, which is exactly 4 bytes. This is pretty small, only 4 bytes. Let's see what we got as a result. As you can see, I got exactly in the same directory, in the same location of bear.asm, this file, 0bear.bin. Maybe you have never seen a bin file before. Actually, there is nothing special about it. This is just some kind of extension. And as you can see, this file is really short, only 4 bytes. What can we do with a bin file? The first thing to try to do is to click on this file, and we get this error message. Windows cannot open this file. To open this file, Windows needs to know what program you want to use to open it. I think that this sentence summarizes it all. The problem is that Windows does not understand this file. You might be surprised because maybe you expected that at this point we will have a program that actually runs. You might be wondering, why can't we just write a few instructions and then assemble those instructions and run them? The point is, reality is a bit more complicated. We are living inside an operation system, currently inside the Windows operation system. If we want to create a program that will actually run, we have to obey some rules. And some of those rules say that we have to add inside our file some information to the operation system. Some information that says how to load the program into memory. And some other things that we want from the operation system. We have to add this metadata or additional information inside this file. And this kind of program does not add this information. Even though we didn't get a program that we can actually run, we still have much to learn from this example. First of all, we can try to understand something about the size of this file. We can see that the resulting file is of size exactly 4. We might try to guess what is 4 or why 4 bytes. A good guess would be to say that each of those instructions, inc, dec, and inc, all of those instructions take exactly 1 byte each. And then all those 4 instructions together take exactly 4 bytes of memory. This is just a guess, but I think that it is a pretty solid one. Let's verify our guess. We're going to open this file with a hex editor. A hex editor is a program which allows us to see the inner contents of a file. So far we have used text editors. Text editors are mostly good to see printable text. But if you want to see binary files, or files that were generated by the assembler, you will have to use something heavier, which is a hex editor. There are many hex editors that you can find out there. Many of them could be obtained for free. I'm going to use Hex Workshop during this course. This is Hex Workshop. In order to use Hex Workshop to see the inner contents of this file, 0ber.bin, we are going to drag this file into Hex Workshop. And this is what we get. We get exactly 4 bytes. If this is the first time that you see a hex editor, let me explain what we really see here. We have 2 sides. On the left side, we have base 16 representation of the bytes inside the file. This is 1 byte, this is another one, and so on. A byte is made of 8 bits, as you probably remember. And therefore, 2 nibbles, or 2 16-bit digits, exactly consist 1 byte. On the right side, we have a textual representation of the data. You will not always have a meaningful textual representation, but sometimes you do have. If we try to open ber.bin using a text editor, for example, maybe Notepad, we can see that we get exactly the textual representation, which is here, this representation. You can see that this one and this one are exactly the same. But it will not always be the case where you have a meaningful textual representation, if you can even call this representation meaningful. Let's keep on with verifying our guess. I look at the program again. And this time I take a specific look at the instructions. I have two instructions of ink, which probably correspond to those two 40s. 40 and another 40. Then I have a deck instruction, and finally another ink instruction, which is probably again 40. I think that at this point we can probably be really sure about our guess, because the pattern really match. Here we have ink, ink, deck, ink, and here we have 40, 40, 48, 40. So probably 40 means ink EAX, and 48 means deck EAX. By the way, those two numbers differ by only 1 bit. So it is probably reasonable in some way. I want to mention another thing about the hex editor. You might be wondering if this is what we always do. We don't always have to open our programs in Hex Workshop. This was just an example to show you what's inside the file. Many people never care to look inside the file, and I think that it's a shame that people don't do this. You can learn a lot of things by sometimes opening your file in Hex Workshop. Whenever I do something new with my assembler, I always want to see what is the result, what is the binary result. And as a friend of mine says, the bits don't lie. You could have lots of text in your program, but eventually the truth is in the bits. Therefore, I really care about what I see in the hex editor. And sometimes I do open the output of the assembler in my hex editor. You don't have to do this all the time, but I do recommend to sometimes do this. How do we continue from this point? We said that we don't have information for the operation system to be able to run this file. I remind you that our wanted result is an executable file, a file that we can actually run. In the next examples, we are going to see how to add this information using Fasten. We will have a bit of a different code because we will have to add more things inside the source file, but the core code or the core part of the program, which is those 4 instructions, is not going to change. We are only going to add some more information for the assembler and for the operation system.